Hello and welcome back to my RC channel. I'm Andy RC and this is episode 6 of building a high-end 450 size quadcopter. In the last episode you saw me make all the connections to the Pixhawk, and in this episode we're going to connect it to the software. So the first thing that you need to do is navigate to ardupilot.com and then in the download section select Mission Planner and make sure that you download this to your desktop and install it. Now, when you do install this, it installs the USB drivers at the same time. I believe if you are on Windows 7, you need to run it as administrator, but seeing as everyone got the free upgrade to Windows 10, I'm not sure how relevant that is going to be. So once you have done that and it is all installed, you can take your USB lead and plug it into your Pixhawk. You'll get the magic bleeps from the computer. And if this is the first time that you are doing it, make sure that it is properly installed the device. So the first time you open a Mission Planner, it will look something like this. The first thing we are interested in are these boxes up the top here. You can see that we've got drop-down menus. And what this is doing is it's telling us which COM port we are using to connect to the Pixhawk through the USB lead. Now, as this isn't a genuine Pixhawk flight controller, it doesn't mention Pixhawk here at all, so you can select the auto option, but as I've plugged this in a few times, I know that it's COM port 3 there. Also, when you're connecting through USB, you want to make sure that this value here is at 115200. Now, we don't connect to it yet. We now have to go into initial setup because now we're going to install the firmware onto the board. You can see there it started downloading everything because there's various different versions you can put on the Pixhawk, but we are interested in Quadopter version 3.21. Obviously, as time goes by, that will change, but I'm going to click on this. Are you sure you want to upload Quadopter? Yes. So that is going to now download the firmware from the internet. And can you see there it says failed to read certificate, but again, that is because we're using a clone version of the board. So if you press OK, it will still load it on. So you can see there it's erasing what's currently on the flight controller, and then it is going to upload it to the board. That can take some time to do, so don't worry about that. Please wait for the musical tones to finish before clicking OK. I have done that, so press OK. Warning, if you are installing it for the first time, you must redo compass calibration. Yes, we're going to go through all that. Press OK. And there you go, we are done. So now we should be able to connect to it. So if we press the connect button up the top there, there we go, done. It is connected. Right, so if we go into flight data, we should be able to move the quadcopter about and the heads-up display moves here. Right, but we need to continue with the setup, okay? So if we go back to initial setup and then mandatory hardware, we've got to fill some things in here. So the first thing we want to do is go into the frame type, and we want to select it as this option, which it already is selected, but it's the Quadopter X version there. Okay, so next I'm going to calibrate the accelerometer, so we'll click on that option. You see there, you click Calibrate Accel. Place the vehicle level and press any key, so it's level there. Press the space bar. Place the vehicle on its left side and press any key. So that's left to the quadcopter when it's facing away from you. So left is going to be there. I'm just going to hold it in place. Doesn't have to be accurate, this. And press enter. Place the vehicle on its right. So on its other side. Press the vehicle nose down. Place the vehicle nose up. I've seen people using set squares for this, but you don't really have to be all that accurate. I haven't had a problem anyways. And then place it on its back. Now it may go slightly out of shot here to do this, because I'm going to have to hang it off the table. Calibration successful, there we go. I'll place it level on the desk again. Now you can see here, we're going to calibrate level, so make sure that everything is level. I do have the battery installed underneath here whilst doing this. It says completed. So I'm going to skip the compass calibration for now. The reason being is you have to move the quadcopter around and this USB cable can get in the way. So we're going to do that through the telemetry module. So the next thing that I'm going to do is radio calibration. So I now have my Tyrannus here. You saw me set that up in a previous video. I'm just going to turn it on.
Welcome to Tyrannus.
Wait for it to boot up.
Stabilize.
And we should see this light go green here on the receiver, and it is connected. So now if we go on to radio calibration and then calibrate radio, ensure that your transmitter is on and receiver is powered and connected. Now the receiver powers all through the USB cable and the telemetry module for now, so we don't need to worry about connecting the battery at the moment, but we will be doing that for the compass calibration. Ensure your motors do not have power / no prop. So yes, we don't have that. Okay, so I'm going to press OK. Click OK and move all RC sticks and switches to their extreme positions so the red bars hit the limits. Press OK there. On the transmitter, I'm just going to do that quickly. Then I'm going to move my 6 position switch.
Return to launch. Acro.
You can see that moving into the 6 positions.
Lighter. Altitude hold.
Apologies for the
Stabilize.
sound.
Return to launch. Acro.
Okay.
Landing.
Okay.
Return to launch.
And
Stabilize.
I think I've also got my channel 7 switch set up for auto tune. You see that? Yeah, I'll show you how to set that up too. No, I think that's everything there. One thing that is important in this is the elevator. Now, when I push the stick down like this, it moves backwards to you. All the other axes move fine, the way that you would expect them to, but the elevator looks like it's the wrong direction. But if you watch my previous video where we set the Tyrannus up, I reverse the elevator and show you how to do that. So this is how it should move. When we put up in, it actually goes down. So a little bit confusing that, but there you go. Click when done. Ensure all your sticks are centered and the throttle is down, and click OK to continue. There we go. We can just press OK there. Okay, so next I'm moving on to the flight modes. This one is fairly straightforward because in the previous video I already set up the Tyrannus to have these. So all we've got to do is select our different modes. So if we look at my transmitter and listen to the sounds that it plays,
Altitude hold.
that's the second mode. So put it to the first one.
Stabilize.
We're already on stabilize. So the next mode,
Altitude hold.
altitude hold. I'm going to change that to that. Move it along.
Lighter.
Move it along, and then that's lighter.
Return to launch.
Return to launch.
Acro.
Acro. These can change as well. You can have whatever mode you like. This is just my preferred mode. Obviously, we've got the auto mode missing there, which allows us to do missions, but I'm not getting into that yet. I'm just setting it up. So that's acro, and the last one.
Landing.
Landing. Okay, then save modes. And that's complete. Should just move then.
Acro. Return to launch. Loiter. Altitude hold. Stabilize.
Okay, so the other thing that we need to do is change our channel 7 so that it enables the auto tune function, because that's what we want to use on our first flight. Okay, so to do that, we go to the config tuning tab. And then under extended tuning, we want to opt for channel 7 to do auto tune. So if we go down there, auto tune, and then write parameters. Yes, that is fine. It's just checking that you want to change it. So another thing that we need to do is alter the stock PID settings. And the reason for that is I am using a 4S with this setup. Now, these settings will work fine with a 3S. You'll get a decent flight, but they're too high for a 4S. Now, all we need to be able to do is get it to fly so we can enable this auto-tune option, but it isn't going to fly at all with these PID settings, so we need to change it. Now, we only need to change these stability settings, I have found. Unfortunately, we need it to sit at around 2, and it's not going to allow me to do that. In fact, if I change that and put 2 in, it only lets me go as low as 3. I think it's the same on the Ural. So to get round this, what I did was I changed channel 6, and what you can do is you can set up a dial to alter the PIDs while you're flying. Now, I'm not really into that, but if we go down here and select stability, and then pitch and roll, we can select 0 to 1000 there, and then if we do right parameters, and then refresh the screen, you can see there that it's dropped down to 0.492. Now it should be able to lift it up to 2. There you go. Let's just change it. I don't know why it does that. Okay, so I'm going to have to do the same on the yaw, so I'm just going to write those parameters. Yep. Okay, and then I'm going to go down here and choose stability yaw. 0 to 1 again. Refresh the screen. And there you go, it's gone down to 0.492, and I'm going to change that to 2. I'm then going to change this to none, so that we don't change any of these parameters anymore. Do right parameters. And there we go, that should be just enough to get us to fly on a 4S. Okay, so the next thing I'm going to do is calibrate the compass, and I'm going to do that through the telemetry module. So I'm going to disconnect this USB cord here, and then I'm going to plug in my telemetry radio here into the computer. Now, if you are doing this for the first time, you might need the FTDI driver. It just worked on mine. But if you go to ftdichip.com and go into drivers and VCP drivers, that's virtual COM port, and then just download it for Windows, and it should be recognized. Just a quick note on the telemetry modules, they come in 2 different flavors, of which I have both variants here. These are the receiver modules that plug into the computer. We have the 900 MHz version, and we have the 433 MHz version. So if you are using UHF for your control, you definitely don't want to be using this one, because it's on the same frequency as UHF, which is 433 MHz. As for the power, these are both the stock 100 milliwatts. If you look online, you can get 500 milliwatts, which means you're going to get more range. However, you're going to get great range out of these anyways, up to a few miles, and that is just using the stock antennas. If you want to go ahead and put UHF antennas on them, you're going to get even further as well. Another thing to note is that when you plug these modules directly into the USB port, you get noise off the connector. So what a lot of people suggest is using one of these cables, which just extends the USB cable so that you don't get any interference. Some people are using USB hubs as well, but this is working fine for me. So now it's time to find a spare USB slot on my computer. I think I've got enough here. Now I'm not going to be using the extension cable that I mentioned before because I am working in close proximity. However, if I was doing a mission or something like that, of course I would use it then so that we don't get any interference. But for now, I'm just going to connect this into the USB slot directly. So this time, we're going to plug the quadcopter into its battery.
Telemetry recovered.
And that should boot up, and we'll get a flashing light on the telemetry module there. It's now gone to a solid light, so now we need to go back to Mission Planner and change these settings at the top here. So this time, it's going to show, there you can see COM4 Silicon Labs, so we select that one, and you can see there it's changed it automatic, but it needs to be at 57600. So now we can connect. Might take a little bit longer because it's doing it over radio. And you can't install the firmware over this, by the way. Okay, so now we can go back to initial setup and do the compass calibration. So the first thing we want to do is go into this compass tab here and select Pixhawk/PX4. Now the reason we do that is Mission Planner is also used to configure the APM device, and the APM device is slightly different. Now there is some conflicting information out there on the internet between the differences in the way the magnetometer works on APM versus Pixhawk. So the APM has an internal magnetometer, a compass, and if you plug your GPS module in with an external magnetometer, you have to change a jumper or a soldered joint. change depending which version of APM it has. Now on the Pixhawk, there's no option for that. It automatically selects it if you've got an external magnetometer. That said though, some people say that the compass inside the Pixhawk and the external compass work together to create an offset. Now, some people say it does, some people say it doesn't. To be honest, I'm not too bothered about that. I'm just going to configure it. So I'm calibrating the compass on the quadcopter itself for a couple of reasons, right? There's some information out there that says that you should calibrate your compass on the quadcopter because there's magnetic interference inside the frame itself coming off the battery, and it needs to calculate the offsets of that so you get an accurate compass reading. My problem with that though is that there's going to be magnetic interference inside the house, so not too sure on doing that. But to be fair, I have done the compass calibration off the frame and got fine results, so make of that what you will. My reason for calibrating it on the frame is that when you move location, you have to calibrate your compass again anyway, so take your laptop with you, whatever, and it's going to be on the frame anyway, so it doesn't matter. I'm calibrating it on the frame through the telemetry module. So, is the firmware version greater than APM Copter 3.1? Yes, it is. Next, we're going to click Live Calibration. Please click OK and move the autopilot around all axes in a circular motion. So I'll press OK here. See, we get this box up here and we're going to get some white dots. Now, can you see there, we've got Use Auto Accept. I've got this turned off because I found that it accepts the values before we have connected all these white dots. So I'm going to make sure that we've got plenty of references before clicking Done. So we literally pick up the quadcopter and move it around. And you can see there using the telemetry module that it is a bit jerky compared to using a USB cable, but it's fine. You'll be able to see that you're getting all the dots just about. And I wouldn't want to do this with the USB cable, hence the reason people doing it off the frame. But this is the best method in my opinion. So we're just moving it around and trying to connect all those white dots. Takes a while this, so you'll have to bear with me. Just got one white dot to get. There we go. Just going to do this a bit more. Doesn't do any harm. Okay, so now I've got all the white dots. I'm going to click Done. It makes a beep. And there you go. Press OK. Now been saved. Okay, so next let's talk about the failsafe. This is very important, this is. So ensure that your props are not on the plane/quad. No, they are not. Press OK. Now we've got some options here. We've got a failsafe on the battery, which basically means that when the voltage drops to a certain point, it's going to perform an action. That's this action here. I'm going to leave this disabled for now because we're going to need to calibrate our voltage before messing with that. But just to get it in the air, we're going to need a failsafe on the radio. Now, if you remember back to the Tyrannus video where I set the failsafe on the transmitter to no pulses, this is the reason why. So you can see here that we've got a PWM value here, and what happens is when you set the transmitter to no pulses, when you turn it off, all of the PWM values drop, and we're hoping that it's going to drop below this figure here. So what we need to do is we need to go into our radio calibration, and you can see there that when my throttle is at idle, it's reading a PWM value of 983. So basically any number lower than that is going to trigger our failsafe. So if we go back to the failsafe mode and press OK, you can see there it's set at 970, but I'm just going to drop it a little bit lower just for safety. We don't want to reduce our trim or something like that and cause our failsafe to kick in. So I'm just going to sit it at around 960 there. And then if we go back to the radio calibration screen, if I turn the transmitter off, what should happen is this should drop low here. So let's do that. There we go. You can see it drops to 874, which is well below what I have set on the failsafe here. So that should failsafe, and we can actually test that. So before we can test that failsafe is working, we need to calibrate the ESCs to get the motors running. So to do that, what we do is we unplug the quadcopter.
Telemetry lost.
And then we take our transmitter and put the throttle up to full. We can then plug the quadcopter back in.
Telemetry recovered.
And you'll see there that we've got a flashing multicolored light there. That tells us that the Pixhawk has recognized that we want to calibrate the ESCs all in one go. So now we unplug the quadcopter again. And when we plug it back in, we keep the transmitter's throttle up to the top there, and the ESCs are going to start calibrating. So let's plug that in.
Telemetry recovered.
You can see we've got the flashing lights there. Now what we need to do is arm it by pressing the arming button here. You can see we've got different beeps this time. Now the throttle is at full, and now I'm going to bring the throttle down. And there we go, our ESCs are calibrated. Now we can unplug the quadcopter again to take it out of this mode.
Telemetry lost. Telemetry recovered.
And now when I plug it back in, it's going to boot up normally. We've got a blue flashing light there to say that we don't have a GPS lock, but that is fine just for setting it up. Before we test if the failsafe is working, we can actually do a quick test on the motors individually. However, if you connected them up in the way that I showed on the build video previously, then the motors will turn in the right direction anyways, but that is what that test is for. So if we go down here to optional hardware, we have got motor test there, you see. And you have to arm the quadcopter in order for it to work. If you press it without it armed, you'll get an error. Command was denied by autopilot. So if we press that, make sure the throttle's down on the transmitter. If we press that in, okay, so now we can do motor test A, and it actually goes from that one and circles around. So motor test A, and that is going, and it only spins at a very low RPM, so you can put your finger on there and see that it's moving in the right direction. Motor test B, this one, motor test C, and motor test D. Now, I've actually got the stock propeller adapters already on here, but I'm going to be removing them for a couple of reasons. The first one is you can see that this one is actually bent. When I first put the propellers on to test it, I tightened the screw up with the socket set and it bent it. So you have to be really careful with that, and I was really surprised. But the second reason, if you saw the first episode where I bought all the stuff, these all have the same thread on, so I had to use thread lock in my initial test, but I've gone and bought clockwise and counterclockwise propeller adapters, but I've just got the stock ones on now for this setup. So now that we have done all that, I should be able to arm it, and you arm it by making sure that the throttle is fully down, and then we apply the rudder. And this light should change. You can see there it starts to blink different colours, and the motors start. And you can see there that we can lift the throttle up and the motors get faster. Now if you put the throttle back down, it will disarm itself after a few seconds. Of course, if you want to disarm it before it stops, you can apply the opposite rudder and it will disarm itself. Now you can actually have it set up where you arm it and the motors don't spin up, they just spin up when you move the throttle. I have since realised though that this is a really good feature. It's difficult to know when your quadcopter is armed and you may forget to disarm it. And when you pick the quadcopter up, you may knock the transmitter and you could end up really injuring yourself. When you arm it and the propellers move, you know that it's armed and that when they stop, it's completely disarmed. So I think that's a really good safety feature that I didn't like at first, but I'm warming to it now. So now I have calibrated the ESCs and got the motors moving, we can now check out that failsafe option. So I'm going to click on the failsafe tab here, Press OK there, and then on the radio where it says disabled, I'm going to change that to RTL, which is return to launch. That saves the options automatically there. So now if I go into flight data and check out the heads-up display there, it says disarmed. So if we get the transmitter and put the yaw in, it arms itself and starts going. If we turn the transmitter off, look where it says armed. You can see there, no receiver, failsafe. It's working. Now you can probably fly this quadcopter at this point and get fairly decent results out of it, but in order to set it up properly, we need to do the compass MOT. And in order to do that, we need to calibrate the power module. That is to make sure that it's producing the right voltage information to the Pixhawk and also the right current. So we'll be doing that in the next episode. Thanks so much for watching. Please continue to subscribe. Cheers.